that leads to a fairly simple question. So I've got servers, and I've got VMs, and I've got Kubernetes, and I've got applications, and I've got functions, and I'm really friggin' confused, right? So what do I run where and why, and maybe even when do I run what? So let's take a look at that and see. So let's go through a little set of charts here about where you run your code, right? So we start at the bottom left, right? We've got servers or VMs. They run existing servers, existing systems, VMs, large databases, and you manage that by managing at a server level where you define CPUs, memories, disk, you load an operating system, you define the networking on each one of these servers or virtual servers, right? You're used for existing VMs. You're not going to change that. If you need to run a VM, you need to run a VM, right? Quite often we run our firewalls, load balancers, databases, monolithic applications, all of these things into a virtual machine. You run that as a virtual machine. So this is what you get in an EC2 instance or a VMware virtual machine or an Azure Hyper-V. All of those things, KVM in the Linux world. Those are all virtual machines. All they are is a virtualization of a server. So then you have containers and Kubernetes. And what we're doing there is we're building these lightweight, reusable servers that can transfer around much faster. They can load much faster, and they're much more lightweight, right? We have to start moving from a machine to a server. So here's where we get out of our pets, where we name everything. We start thinking about them as cattle, where they have this long string that identifies them, but they can die, they don't live that long, and they're expendable, right? And we're going to manage that as a cluster of resources as on a pool basis. So here we're actually taking a set of servers and running them as one sort of compute and storage pool, right? And we're going to let the machine actually figure out what to run where and how to keep things alive and those types of things. We're going to define our desired state, and we're going to allow the machine to give us the closest to that desired state as possible. Okay, so moving up one layer. Well, we know what an app is. Instead of running this super lightweight server, which is what a container is, we actually only care about the application. So we go back to the thin app model you used to maybe know about from VMware. What we're really looking for there is usually some web-facing code, but maybe something that needs to always be on, that may have I don't know, some back-end processes that have to run with time, or a cleanup process, or you have to make sure that something completed, multi-step thing completed. So you still keep your app on all the time, and you're going to pay for that app to be on all the time, right? So it's usually a highly scalable application that's always on, right? The step above that is functions, where a function is in stasis. It's not always on. It's always available, but it's not on and running. And you're actually just managing the code, not the application. So you're writing a small bit of code, and you're pushing that code out to the internet, and you get a pointer back, a DNS namespace of how to reach that code. It's completely decoupled from the thought of a server, right? It's code in the cloud, whereas apps, containers, and virtual machines and servers, we're still thinking of those as an actual application running on a server somewhere. The functions you have to think of differently. They only execute when you poke them, and as soon as they give you some response back, that's it, they're gone, right? So you have to think about how to glue these together into a system. All right. Let's talk about the organization that you would want to use these things for and the level of automation and access you have at each layer. So if we start at the bottom again, we have our traditional infrastructure. The teams we talked to today, these are our usual model where we have infrastructure laid out in servers and storage, or infrastructure as a service, where our organization is very traditional. So we have a a development team usually, and then over here we have the operations team. And the code gets thrown over the wall after it completes QA, and it's up to the operations team to run it, right? And they're going to use some automation to run servers and deploy things using their traditional data center tools. And they're going to give back a DNS entry once it's all set up to actually access the server, right? And it may be a load balancer, and then that, reaches out to multiple servers, but generally it's a single point of entry. So as we move to a DevOps team, here your operations are automated to a point, and you've started to containerize things where your ops team is just some nebulous sort of overlapped point with your development team, that your ops team is making sure that stuff is running and is running up to the SLA that you've defined, right? And they're helping make sure that the cluster has enough resources, that auto-scaling's working, these types of things, and that when you point to a DNS entry, you don't care what server it's running on, you just care that you're getting a response that meets your SLA. So this is where we get into the new DevOps world, and this is where a lot of people are talking and thinking as they go, as they refactor some of their virtual machine applications and server applications into containers. To go up to one more step, developers sometimes don't really want to care much about operations. This is your platform as a service sort of level where you abstract the operations completely out from the app developer. And the app developer really just checks in their code, and as long as it's running, they're happy. So they're not involved in as much, how I need to run this. They don't have the operations person necessarily sitting next to them. They're just going to check their code in and let somebody else deal with it. And this is a true apps-focused point of view. And you can buy this from any of the major cloud providers. It's very much limited as to what you can run because they don't want you to break out and break anybody else's apps. But it is a nice way if you're a much smaller provider, if you've provided, say, a cell phone app to run the internet side of the house. And finally, your functions as a service people, they're just writing, a paragraph of code and posting it up there, and everything is automated, and they get a pointer back. And that's 100% automated system. Even if you're giving out apps and functions and you have an operations team, they're all working down at the containers and Kubernetes level, but your programmers are thinking really, I don't have to worry about any of that. That's all taken care of for me. And they're truly development focused, truly coding shops, and really don't care where it's running in the world, right? Just as long as it's running. Okay, so what I didn't talk about in any of this is how this is billed and how you pay for it. So let's take a look at that, right? Who is responsible for the updates, how it's billed, and what are some of the products' names as I talk about each one of these. So this should help you get your head around exactly how these are done. So on the server VM, you do all the updates. You're responsible for patching the virtual machine, the operating system, the code itself. You pay per server based on the size, whether it's a tiny or a huge or a high RAM version. And again, this is your EC2 instance or your Azure Virtual Machine or your Google Cloud Platform. On-prem, it's your VMware, Hyper-V, KVM, or a Nutanix AHV. So you're all used to this, and you're used to how we do this. But when you get to the container world, some people are like, oh yeah, I'm just paying per container. You're not really. You're actually paying for this whole pool of resources, but you're still spinning these up, right? You're still paying for the same virtual machines down below. You're just not managing it the same way, right? Kubernetes provides you a good way to do automated rollouts. Interesting thing, and I don't remember if I showed this or not in any of my demos, but you can actually do an update of your API server and as long as it's completed in 300 seconds, your worker nodes just keep working. They don't ever have a problem with it. They don't panic. They let you upgrade your API server, and they just keep the world running as to the last known good one. If you tell the worker nodes, if you tell Kubernetes you need all the worker nodes patched to this patch level, it will move all the components off this worker node, upgrade that worker node, bring it back up. If it runs okay, move everything back onto it and do the next one. It'll do automated patching. So you start to, maybe you have a master and 3 worker nodes, but you're really paying for 4 virtual machines. So you really build the same way as you are below that as in virtual machines, right? You're just managing it in a different way. So that's kind of a gotcha for most people to understand. Kubernetes Containers gives you an automation level. It gives you a nice functionality, but it really doesn't change your billing methodology as much as most people think. And furthermore, the app side of it, you just upgrade your code, it rebuilds the container and relaunches it, and some of the products here, AWS Elastic Beanstalk, I didn't go through the products below, but they're all just Kubernetes or container services, you'll find them. But the apps level, you have AWS Elastic Beanstalk, you have Azure Cloud Service, you have Google App Engine, you can do on-prem Knative or Pivotal, these setups. So, but you're still paying a small virtual machine for that app. You're actually going to set aside all the memory, all the storage, and all the CPU it's required. So you're going to define what you need for that app, and you're going to pay for that on a monthly basis. So it's still really buying a small virtual machine to run that app. Where you really get away from that is when you go to the function as a service. So just your code gets updated on a web page. You can go pop your code into either AWS Lambda, Azure Functions, or Google Cloud. They will automate the deployment, everything on the back end, and they charge you only per 100 milliseconds of unit of work. So this is the first time you're actually billed on a time basis. So it is finally different, because the 3 below, they're just different ways of selling you a virtual machine. Out of that top one, you're really paying on a time basis of when your code runs. So it's much more like electricity there. Okay, so now that we understand that, and we can help people with how their organization is structured, et cetera, and what kind of code they need to run, what does it mean more for us as Presidio? You're going to see a whole lot more of white box sort of sales, where they're, if you're talking to the infrastructure team, they may say, I want a Dell or I want a Cisco, et cetera. But when you're talking to the services or the software teams, and it's infrastructure as code, they don't care as much about the brand. So as you go talk to these people, don't lead about brand. In fact, if you don't, they'll let you choose the brand quite often. They don't really care as long as it's not overly priced, right? The other thing is, they're not looking for a lot of, these speeds and feeds and all those types of things. They don't really care, because it's all abstracted away from them. It's all automated, right? So they're probably more willing to buy 5 cheap white box servers than 4 Cisco or Dell or HP servers. And if one dies, so what? Right? We'll just buy another one. So that's more the mentality that you get. They tend to treat storage as just a bunch of drives or just a bunch of flash. There are a lot of opportunities here to take the data and copy it off, right? So secondary storage is huge, and cloud object storage is huge. And you also probably want to start looking at the NVD RAM, which is non-volatile RAM. So if they have a power outage, the RAM writes out its current state you fix whatever the problem is, or the power comes back on, it simply loads it back into memory, and then it just keeps going. So that's more of the data center disaster recovery version that they're interested in. They're not looking for a lot of bells and whistles out of their networking systems, because a lot of it is obfuscated away and hidden in a couple layers and software controlled. So again, what all this tells you is leading with brand here, and that isn't as much a focus with the software side of the house as you start to talk to the line of business. But if you're not involved with, if you are involved with them early on, you can choose the brands more or less. If you're not involved with them, somebody else is just going to sell them a white box, right? Or even worse, they're just going to go out and buy something off of Amazon.com and or Supermicro, because they don't care, they don't know, they don't have to support it, right? For us, for professional services, we're going to see a lot more Linux skills, install config. We need to know more about development, about Git and the CI/CD pipeline. So we started to teach all these things. We're also using these same tools to actually define networking as well. So networking has become NetOps instead of DevOps. It's going to become very much more important for us underneath to do the architecture. So planning, creating policies, creating a lot of the templates, if you will, a lot of the text files that we've seen that help people understand, as well as providing them with a capacity growth plan. So a lot of the architecture is going to be much more on us as you go into a software group, right? We're also going to have to work with them to convert policy and intent to instruction sets. They may not know some of this, so teaching the ops team how to shift from normal operations to a DevOps model. And this is something we've been doing with some customers. Again, if you're not involved with the architecture discussion today, and somebody else is driving that, and you come in and you say, okay, I want to sell you some of this great brand X gear, they're going to say, oh, no, we're just going to go purchase this. We don't need salespeople to sell us anything. It's really going to be a different mindset if we're not careful on this. So I hope you enjoyed this presentation, learned something from it, and hope it took some knowledge as to where we're going in the future with some of this stuff and what it means to you. So thanks a lot, and we'll talk to you soon.